Last time we derived the equation for the orbit shape, which says u double prime as a function of theta is equal minus u of theta plus k mu divided by L squared, which is true only if force is given by minus k divided by r squared, and our u is simply 1 over r. Now we solve this equation. We can substitute u with w, which is given as u minus the constant k mu over L squared. Then we get from the equation of the shape of the orbit w double prime of theta equals minus w of theta. Well, this is just simple harmonic oscillator. We know how to solve that. The solution is w as a function of theta is given by, say, a times cosine theta minus theta 0. We can set theta sub 0 to 0 by choice of direction. Then we have u of theta equal k mu L squared plus a cosine theta, or k mu over L squared 1 plus epsilon cosine theta. Now we can inverse u and find r to be some constant c divided by 1 plus epsilon cosine theta, where constant c is simply L squared divided by k mu. We can recognize r of theta as the equation of conic section. We see that the orbit is going to be a conic section. We have the minimum distance of the radius given by c 1 plus epsilon and maximum given by c 1 minus epsilon. The point with the minimum radius is known as perigee, which is a Greek word, has two parts. Peri means near and G means Earth. So this applies if you have a satellite. Or perihelion if a planet is orbiting the Sun. And if you're not sure, you can simply say periapsis. So a planet orbiting, say, another planet or black hole. Likewise, for Rmax, this is called apogee for an object that orbits the Earth, and apo means away. Or aphelion if you orbit the Sun, or apoapsis, simply orbiting some object. Let's take a closer look at eccentricity epsilon. If epsilon is equal to 0, then we have a circular orbit. If epsilon is between 0 and 1, then we have an elliptical orbit. If epsilon is equal to 1, then we have a parabolic orbit. And if epsilon is greater than 1, then we have hyperbola. How is epsilon related to other parameters? It's given by square root of 1 plus twice full energy, angular momentum squared, divided by mu k squared.